Please welcome to the stage, Grant Faber.
All right. Hey, everyone. Hey, very good to see you all. I'm Grant Faber. I formerly was the DAC Hub's program manager at the Office of Fossil Energy and Carbon Management at the Department of Energy. Unfortunately, was laid off by the Trump administration, and will now be going to work at a startup called Offstream, doing LCA and MRV. I'm going to be talking a little bit today about the report that I compiled while at DOE, specifically focused on a very precise definition of direct air capture, as well as a global company analysis. And this whole work was actually based on a Google Sheet, just random list that I made as part of my Substack carbon-based commentary. That was probably, I think it was maybe late last year or so. And so some of you in this room may have contributed to that, may have submitted company names or other information to help fill that out. But yeah, it's been a very interesting effort in trying to track the global evolution of the DAC ecosystem. So hopefully it's interesting, and hopefully we'll have some fun. So I actually want to start with a little historical lesson about DAC and where it comes from. So this little story here comes from a book, Scrubbing the Skies, about the history of the DAC industry, which if you haven't read it, I highly recommend going out, reading it. It gives some very interesting insight into the early formation and evolution of the DAC industry. There's a story that's shared in there about how DAC, if you define it kind of broadly as just anthropogenic removal of CO2 from air, may have first actually been discovered before the US was even a country in the 1600s by this Dutch inventor, Cornelius Jacobzoon Drebbel, to actually remove exhaled carbon dioxide from subs that were being invented at the time. And it makes sense, and it's actually still a technology, CO2 scrubbing, that's in use today in subs and spacecraft and so forth. So it's actually been a long-standing problem. And so it's interesting to see how the technology has evolved. And it's not like the specific chemical reactions aren't totally known. And this whole story might frankly be a bit apocryphal, but it's theorized that the technology could have been potassium or sodium hydroxide for the CO2 removal, which, of course, are sorbents that are still in use by some today. So, kind of interesting. And so, okay, who in here is a fan of the movie Fast and the Furious? You can raise your hand. Okay, so we got some. So if you're a Fast and Furious fan, you may remember from Fast and Furious 1, there's a famous scene where Dom, played by Vin Diesel there, yells, "The Busta brought me back," okay? And so I was inspired to put him on the slide because Dr. Klaus Lackner brought DAC back from maybe being hidden in like an ancient Dutch sub under the sea. But more seriously, there's a story in Scrubbing the Skies about how DAC actually came to be in the 1990s to be conceptualized as a potential climate technology. And there's this report published at Los Alamos National Lab where Klaus and several others were working at the time trying to visualize this. That was one of the earliest proposals. And what's really interesting about this is that it proposed also a calcium oxide, calcium hydroxide looping process, which again is still in use today. And there's been a lot of innovation on that front. So pretty neat to see this historical trajectory come to be. So I noted that this report that I worked on while at DOE was really focused on establishing that precise definition of DAC as a form of carbon dioxide removal, or perhaps just a technology that can give us circular CO2 to use in low-carbon fuels and chemicals, and then also some company analysis, which I'll talk a little bit more about. It was interesting because the whole DAC definition thing almost stemmed from, I wanted to just first do a report on company analysis, look at every DAC company in the world and try to glean some insights from that. But the attorneys at DOE were like, well, you need to come up with a precise definition of DAC, otherwise you're going to have all these companies trying to be on the list, and how are we going to say who's in, who's out? So I said, okay, well, that's actually a very interesting challenge because there are definitions of DAC that are out there from a lot of different very reputable entities, but all of them had some kind of imperfection, some kind of edge case, something that wasn't totally inclusive. So I said, okay, let's work on trying to develop something that's a little bit more precise. That we can use maybe internally at DOE or even more broadly in the industry to try to determine, okay, what's DAC, what's biomass carbon removal and storage and so forth, and how might we differentiate between these things, what implications might that have as we're strategically planning for future of carbon dioxide removal in the United States or around the world, and then what might that mean for our innovation funding as well. So as I mentioned, this work is trying to establish that robust, precise definition, and then say, okay, who are all the companies in the world developing a technology that meet this definition? What are those technologies and what can we learn from them? So this is the definition. So I'm going to walk through it. So direct air capture is a technology that regenerates a capture medium in a closed, I'll just read it first, then we'll go through line by line. Let me go back here. Direct air capture is a technology that regenerates a capture medium in a closed loop and or uses a mechanical air contactor to chemically or physically separate carbon dioxide directly from the indoor ambient atmosphere without reliance on above average CO2 concentrations caused by nearby point sources of emissions. So it's a lot of words here. It actually took months to put this all in one thing because I kept finding different edge cases, different things. What about this company? What about that? And so walking through it, well, we have regenerates a capture medium. So that allows for reactive capture, which is one of the main categories of DAC I'll talk about on a following slide. Capture mediums that include solid sorbents and liquid solvents. And then we'll also talk, there are membranes and cryogenic approaches as well. Having that capture medium circulate in a closed loop is important to differentiate from direct ocean removal, where that might technically be regenerating a capture medium of seawater, but you're putting that seawater back out into an open loop rather than having that in a closed loop system. So that was the key thing that actually made this definition work because it allows for direct storage DAC with no regeneration, where you're just capturing that CO2 and then not regenerating a capture medium. Or there are other kinds of direct air capture technologies like Heimdall, and I know Matt, that's in the room somewhere here, that do not necessarily use mechanical air contactors for the sorbent air contacting, but do regenerate that capture medium. So that was key to include here. Mechanical air contact, so that word mechanical, chemical, physical, we're excluding any biological, photosynthetic separation, which would be in other categories. CO2, so we're excluding any kind of CH4, nitrous oxide type, capture or destruction. Outdoor, indoor ambient, so there's indoor DAC systems that might rely on slightly elevated CO2 concentrations from people exhaling, which actually goes back to the submarine example from the beginning. I may leverage slightly increase. So there's the indoor case without reliance. And so obviously, we want to create a distinction, as many of us face, between CCS and DAC, or point source CCS and DAC. And so there's also been proposals, what if we put DAC like downwind from a power plant that's emitting that has these higher concentrations? Well, in our definition, we classified that as point source as well. So given that definition, 3 categories emerged. We have CO2 concentrating DAC, which is the normal customary type of DAC that most of us imagine, capturing CO2, regenerating that sorbent over and over again. You have reactive DAC, where that sorbent latches onto that CO2, but when you do that regeneration and that desorption step, it's not coming off as CO2, it's coming off as methane or methanol or maybe some kind of carbonate. It's not being desorbed as CO2, so that's reactive to some kind of valuable product. And then direct storage DAC, where there is no regeneration, you're just maybe circulating an alkaline feedstock in a mechanical air contactor, it's reacting with that CO2, then you get some kind of carbonate product that you might dispose of. And so that type of DAC is important because you don't have to deal with downstream gaseous CO2 storage, so it may provide some benefits there. I have a tiny note here that there can be some overlap maybe between direct storage DAC and enhanced mineralization or reactive capture and CO2 conversion. There's nothing saying there can't be overlap here as we're just creating our own definitions. Something important to note, we won't go through everything here, but essentially the report listed all these companies that fit these criteria, so it was really focused on just private incorporated companies. Then conducted some analysis of them. So here are the high-level results here. So 121 CO2 concentrating, 13 reactive, 8 direct storage. There are several other companies that are much earlier stage that didn't get included in this report, so this number might be slightly higher, but there are some fringe companies that have maybe gone out in the time since. I think several people today have hinted at potential consolidation that might be occurring here due to various factors. And so this number may go up, may creep up a little bit over time as some new companies come to the fore and as maybe new ventures are launched, but is perhaps expected to decrease as we see this kind of consolidation, which could be through M&A or bankruptcies. So I listed some notable examples to date there, but that's maybe a positive or negative trend depending on how you look at it. So just in terms of some high-level results for the company analysis. So we have DAC on every continent, which is exciting, except Antarctica. Vast majority here in the United States, and then a smattering Europe and Canada, but yeah, you can see this is a very lopsided graph. In terms of the types of sorbents that most are using, so I classified these as solid sorbent, liquid solvent, and this is the actual capture medium that is interacting with the CO2. And then there's a few membrane and just, I think, 2 or 3 cryogenic DAC companies on the margin. Many have concerns about viability of membrane-based and cryogenic, which could be why it's a much smaller slice, but this is subject to change over time. Interestingly, for liquid solvent, only these companies listed here solely use temperature-based regeneration, whether that's low or high temperature. Most of the other liquid solvent DAC companies are using some kind of electrochemical regeneration, which is, of course, a very interesting and perhaps exciting trend that we're seeing evolve here. In terms of the specific regeneration methods, so there's different splits here. Some maybe have options to use multiple, some are using multiple at the same time. We're really seeing temperature and vacuum and electrochemical as the predominant means for regeneration now. And there's that sole temperature one on the far left, but a lot of companies, it wasn't entirely clear from reviewing their websites or their academic publications whether that's like they were using temperature and vacuum, so sometimes they weren't fully disclosing that. So most are falling in this category. Just some other notable trends I wanted to point out in terms of numbers of companies in particular categories. We're seeing a few, for example, work on things like co-production of electrolytic hydrogen, mobile sorbent systems where instead of having a stationary sorbent, you're moving that sorbent between the adsorption and desorption steps. You see a few on the margins with moisture and humidity swing, some companies using porous crystalline materials, a handful doing passive capture using membranes, and then there's a healthy number at the top there that you can see they're CO2 concentrating, so they fit in that first category we talked about, so they're not specifically reactive capture, but their companies are largely focused on producing low-carbon fuels and chemicals with that captured CO2. So, as I think we all know today, we're all sitting in this room talking about these things. We still have a very long way to go. The average DAC company is this US headquartered amine-based solid sorbent company using motive, so not passive. So they're using fans, temperature, vacuum, swing, absorption. But given that, even with that said, technological diversity is certainly important because we can't fully predict what's going to be the winner or the lowest cost. And there's also different geographies where different types of DAC might be best suited. So further core advances, I think many of us know this, but we need to push the Pareto frontier among all these different parameters and objectives that we're trying to optimize for in direct air capture. So at DOE, we talked a lot about advances in form factors and looking at all different types of form factors, advancing those, using machine learning for material design as well to really advance the fundamental material, which is at the core of all DAC processes. And then, of course, as we all know, true success isn't just about technological innovation, but of course a number of exogenous factors that are necessary to propel the ecosystem forward. So with that, I just want to throw out a few acknowledgments for folks who participated in this effort and helped out. But other than that, yeah, hope this was interesting and enjoyable for everyone, and feel free to catch me after if you have any questions. Thank you.